Hello Pierre, so I'm gonna show you how I generated 2D projections using a 3D volume. So let's start by uh, seeing the volume. So last time I tried to show you this volume, but it was dark. You can only see a dark cube, so that was because the background voxels were dark and the object itself was had light, clear voxels. So let's focus on the object here. So this is the object, and we will generate projections using the rotation around the y-axis, and we're just gonna take half the object. We're not gonna do a full rotation. It's just gonna be 180 degrees between minus 90 and 90, and we're gonna take a snapshot every time we do a 15-degree rotation. So let's run the code and see what happened. So here we can see the first projections. So we will end up with 12 projections here that we can find here. So here we go, 60, 75, and 90. So here we go, the 12 projections. So now, what I did with the NumPy volume is that, let me first comment the code for the .mat volume. And that's it. So what I did is took the 3D Z stacks and using Fiji save it as an HD F5 object file. Then here on MATLAB I read the file, convert all the values inside of this matrix, 3D matrix, into a double. And then since when I do this conversion I had like a very values that are very close to zero, so I multiply everything by 1,000, which will keep the zeros and amplify the 0.008, for example, values to 800 or no 80. So so let's run the code. Let's see the volume first. So I already run the code, so all the volumes are in my workspace. So it will be voldb, voldb, import from workspace, voldb. And here we're gonna do the same thing. We're gonna focus on the object, not the whole volume. And so this is the object. I used on this piece of code, so editor, run. The other files will be overwriter because we kept the same projections parameters between minus 90 and 90 with a 15 degrees snapshot. So let's So this is basically the projection of 12 projections of the tubes that the tube that I showed you, and so it's a 50 by 50 by 50 volume, and this is what we got. So now the next step would be to translate this code to MATLAB, to Python. Here in MATLAB, the FFT and the inverse Fast Fourier Transform functions are already implemented inside of MATLAB, so I'm gonna try to use the NumPy library and use FFT and IFFT functions to do the same on Python, and hopefully work out. And then find a way to use a GPU, definitely, so we can run 2D projections on bigger volumes than 50 by 50 by 50. So I think it's pretty much it. Let me know if you have any question. We can also have a meeting next week, any time of the day, anytime during the week or even in the weekend. Let me know if you have any question by email, and have a good day. Bye bye.